over domain 3.2, applying security principles to secure enterprise infrastructure. So we have a lot to go over in this slide deck as well. We have infrastructure considerations, different types of network appliances we can do to we can deploy to protect our enterprise, and then we have various secure communications we want to talk about and selection of effective controls. So to start out going over infrastructure considerations. So infrastructure considerations involve the strategic planning and setup of an organization's network architecture to ensure robust security and efficiency. In lesser terms, defense in depth. Device placement. So device placement is strategically positioning network devices to optimize security performance and reliability of the network infrastructure. A lot of times we see this with wireless, right? Device placement is big when it comes to Wi-Fi because we want to make sure we have solid coverage for all of our users and roaming users. Device placement when it comes to wired networks can also be something we want to think about, but more or less it's going to be our cabling standards at that point, right? Like if we have a comms closet 100 meters away, maybe we want to do multi-mode fiber instead of like Cat6. Security zones. So we can talk about this logically and physically. Oh, excuse me. Let me go back. Security zones are segments within a network where specific security policies and access controls are applied to regulate traffic and resource access. So we look at this on a diagram. In traditional networks, that is, we're not going to go over our hybrid networks where the boundaries are not very clear, right? We kind of went over that in zero trust architecture. In traditional networks, we're going to have different zones. So we can have what's called the inside zone. The inside or internal zone is also going to be known as the trusted zone as well. This is where we're going to have, I'm going to put the firewall out here. That's the inside zone. This is where we're going to have our internal architecture. All of our users, right? All of our switches, network infrastructure, wireless access points, our servers. That's going to be our inside zone. We can then have something called screened subnets or demilitarized zones. This is where we can have public-facing and internal-facing servers and architecture and services. And then we have the untrusted or outside zone. This is going to be the internet, right, guys? So this will be our provider edge router to the ISP. So here we have something called a screened subnet. So in here, we're going to have increased monitoring, logging. We're going to have increased security. Technically, right, in traditional networks, traditional security, we say that the inside and internal zone should already be trusted, meaning that if you're on this environment, you should already be authenticated and authorized properly, okay? That's in a traditional network. So we can segment our network into these different zones and then apply additional security measures on zones that aren't as trusted, like this screened subnet here, and I'll write out the full name. Or this outside zone. How do we secure this better? Just make sure we have proper filtering right there with ACLs and our firewalls. Attack surface. So the attack surface of the system is the sum of different points, attack vectors, where an authorized user, the attacker, can try to enter data or extract data from an environment. So that's one way to define it. The attack surface is just anything that's vulnerable on our system, right? So the attack surface of a company's website, what ports are open? Is it secure? Do we have VPN capabilities into our enterprise, right? With our attack surface, from a security perspective, we always want to take measures to reduce that surface. We want a low attack surface, right? We don't want a bunch of different points of entry and attack vectors, okay? Connectivity. So connectivity in the context of enterprise infrastructure refers to the methods and quality of connections between device and network segments. So as a cybersecurity engineer, we got to think about the different ways users that are on-prem or remote are connecting to our enterprise resources and accessing their data and our enterprise's data. Is it secure? We got to think about our wired versus wireless networks here. If the remote users, do we have a VPN? Are we constantly authenticating them? Do we have multi-factor authentication set up? How are we protecting that data in transit? If we have a remote user, do we have the proper encryption and VPN established? If we're doing all this encapsulation with encryption and VPNs, is the performance optimized? Are we lowering our MTU fields to allow for those data packets not to be fragmented? So we got to think about all the ways we connect and potentially what we have to do to ensure that we have seamless connections. All right, failure modes. So now let's go over the different types of failure modes. So these are the various ways in which a system component can fail, and understanding them is crucial for implementing effective security measures. So let's go ahead and just jump right into it. So a fail open. So a fail open scenario refers to a security system defaulting to allowing access or continuing operations when it fails or malfunctions. So with the fail open, maybe something got breached, maybe a component of our system failed, but it's still allowing data to transit or transmit, and we're going to allow operations to continue, even if it might expose the system to potential vulnerabilities during the failure period. Good example of this is I've worked on a network before. We have proxies that are supposed to be forward proxies, right? So our users connect to that proxy. The proxy connects out to the internet or web servers, right? And if this proxy fails in a fail open scenario, this computer will still be allowed now to make direct connections without using the proxy, okay? So that's kind of an example of a fail open scenario. Fail close. So in a fail close scenario, the security system shuts down the operation or access it controls in case of failure or malfunction. So with a fail close, this is going to prevent potential unauthorized access or breaches during system failures. So it's different. If that proxy fails in this example, so if we draw it out again, we have my forward proxy. Call that a forward proxy because it sits on our enterprise, reaching out to the internet. If it fails, we're not going to be able to do connections, okay? That would be a fail closed scenario. Device attributes. So device attributes are inherent properties or characteristics of a network device that define its roles and capabilities. So what we could be saying here is that if we see that a mobile device is connecting to our web server, we're going to display the mobile web front end, right? That's just a simple way that device attributes can be explained and how we serve that customer or that user, okay? This also can be useful in security policy, enforcement, and enhancement. So attributes are crucial for applying appropriate security policies and access controls based off the device's role and capabilities. This also can be used for user management as well, right, guys? Like we've talked about when you access our learning management system. When you log in, we're giving you access to our learning management system, but we're going to assign you an attribute that says, hey, you're a part of the Sec Plus course, so we're going to allow you to access our Sec Plus course material and that training program. Okay, active versus passive monitoring or management. So this refers to whether security systems actively intervene in network traffic or monitor and report without interfering. So with active management and monitoring, this is going to be like our IPS systems, right? Which are looking at the traffic flowing and are taking action against that traffic, okay? So if we see an anomaly on our network and we have a run book or playbook that says, cut off that connection, that's active control. Passive control or monitoring is going to be, okay, we're doing our log dives, we're going through, we're seeing what's going on, and now after the fact, we're going to say, hey, that was a potential security vulnerability. Let's go through and make a change now. So inline versus tap/monitor. So this delineates whether a security device is directly in path of a network traffic or observing traffic passively, okay? So inline devices, they're going to directly influence network traffic with the ability to block or modify packets in real time. Again, kind of talking about our active management here, like with a firewall that could be doing filtering, it's going to actively look at that network traffic. With tap or monitor devices, they're going to observe and record network traffic without altering it, and they're just going to provide insights. This could be like NetFlow, right? Where if we have a NetFlow dashboard configured, we can just see our top talkers. We can see what's going on our network, what our users are accessing. So strategic placement. So the choice between inline and tap/monitor all depends on the security objectives, your performance requirements, and the need for real-time intervention. All just depends on what your organization is going to prioritize. All right, let's go ahead and do our check on learning. Hold on, let me bring that up. All right, come on, baby. Let me just come in the back way again. Domain 3.2. Believe we're in infrastructure considerations, right? Yes. Okay. So question 1, which of the following best describes the primary purpose of implementing security zones within a network infrastructure? So A, to centralize all security management tasks. No, that's not going to be why we do security zones, right? That's more like controller-based networking. B, to segregate the network into areas with distinct security policies and controls. C, to monitor and filter out malicious network traffic. Or D, to increase the network's bandwidth and performance. So we're going to go with B here, to segregate the network into areas with distinct security policies and controls. All right, question 2. Which type of security device placement is characterized by observing and recording network traffic without altering it, thus providing insights without impacting traffic flow? That's going to be tap and monitor. So that's going to be just giving us insights after the fact, right? Question 3. In a network security setup, which type of device would directly intervene and possibly alter network traffic based on predefined security policies? That's going to be an active device, right? An active device is going to be something like our IPS systems. Question 4. In a high security environment where data protection is prioritized over maintaining continuous operations, which failure mode is preferred? That's fail closed, right? That's as if one of our security measures fails, we're going to stop everything, right? Data is no longer going to pass. Question 5. Which of the following actions is most effective in reducing the attack surface of a system? Let's go through here. So increasing the number of administrators, no. Installing additional software and services, no. Let's go with C, disabling unnecessary services and ports.